For sections 1.6 and 1.7, we will be reviewing parent functions and their transformations. Okay, so for this first rule here, y equals f of x plus c, if you're adding a constant to a function, you're increasing the y value, so it's going to move c units up. If you're subtracting a constant, it's going to move c units down. Okay, if you're doing f of x minus c, this is affecting the x value or the horizontal distance. So if you think about how to recenter this, I would have to plug in a positive c. So this actually moves c units to the right. Okay, and in order to kind of recenter this one, I have to plug in a negative c, which is why this moves c units to the left. Okay, and then for reflections, if I put a negative in front of a function, I'm changing all the y values to the opposite sign. So it's reflecting over the x-axis because the y values are changing. Okay, if I change the x value to the opposite sign, it's going to end up reflecting over the y-axis. Okay, and then if I multiply the function by a constant, it's a vertical stretch or a vertical shrink depending on the value. If it's greater, if the absolute value of that value is greater than 1 or less than 1. Okay, so for example 1 here, it says describe the transformation that occurs for each graph and then use the graph of f to sketch the new graph. So for this first one here, I can see this is y equals f of x and then there's a minus 3 at the end, so this is going to go down 3. Okay, I don't know what the equation for f of x is, but I can see that the graph here. So if I move each of the points down 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I re-sketch the graph, that's f of x, moved down 3 units. Okay, let's see. For the next one, f of x minus 5, that's going to go right 5, and then it's going to go up 1. Okay, so if I want to translate this right 5 up 1, I could take each of the points or the vertices, or I could just draw it based on viewing things. Okay, let's see how this looks. Okay, translations are rigid transformations, so it should look like the same shape, it's just got moved. Okay, y equals negative f of x, that's going to reflect over the x-axis because I'm changing the y values to their opposite signs. So instead of this being at y is 1, it's y is negative 1, y is negative 1. This 1, 2, 3, 4, 1, 2, 3, 4. This is 1 goes to negative 1. That's also a rigid transformation, so it's when it reflects, it keeps the same shape. Okay, and the last one's an example of when you switch the opposite x values, you're going to reflect the y-axis. Okay, which means this guy is going to go over here. This point's going to go over here. Let's draw that in. Okay, and then this one's going 1, 2, 3, 4, 1, 2, 3, 4. And it sticks out a little bit. Okay, it looks the same, so I'm probably doing okay on that one. Okay, there is one parent function that might be new to you. It's called the greatest integer function. The greatest integer function is the greatest integer that is less than or equal to x. It's sometimes called the floor function as well. I'm going to write that. Okay, and your book uses the notation with these double brackets. I've also seen it written like this, where it actually looks like a floor. It's saying it's the greatest integer less than or equal to x, as opposed to the ceiling, which would be the opposite. Okay, so the greatest integer that is less than or equal to 3.1 would be 3, because that's less than or equal to 3.1 and it's an integer. Okay, the greatest integer less than or equal to 3.8 is also 3. Okay, the greatest integer less than or equal to 3, well, 3 is an integer, so it is equal to 3. Okay, the greatest integer less than or equal to 1/2. Since 1/2 is not an integer, the next lowest one would be 0. Okay, and then if I do a negative, negative 2.7 is not an integer, so the next integer less than or equal to it would be negative 3, because remember, it has to be lower or equal to it. Okay, now we're going to consider the graph of the greatest integer function. So why don't I start out by using the points that I have above. So I know that the greatest integer function of 3 is 3, so that's definitely on my graph. Okay, now if I do 3.1, that's also 3. If I do 3.8, that's also 3. That makes sense. Now when I get to 4, the greatest integer less than or equal to 4 is actually 4. So at 4, it has to hop up to here. Okay, but if I get to 3.999, that's going to stay down here. So I'm actually going to show that by doing this. At 4, it jumps up to the next level, but 3.99 to 3 is going to stay there. Okay, so this is 4. If I do 4.1, the floor is 4. 4.2, the floor is 4. 4.9, the floor is 4. When I get to 5, the floor is, it's no longer 4, it goes up to 5. You can see this little step pattern. This is called a step function. Okay, so same happens at 3. If I'm exactly at 3, the floor is 3. If I go to 3.999, it's 3, but once I hit 4, it hops up to 4. Okay, once you can kind of see that pattern, I'm going to go ahead and continue it. Okay, so that's the general parent function of the greatest integer function. Okay, the next four are parent functions you are familiar with. I'm going to regraph them real quick. X squared is a parabola, 1, 1, 2, 4. And I would want you to have a couple clear points if you were graphing something like this. The absolute value of x makes a V shape. So 0, 1, 2, 3, okay. And on the negative side, the absolute value of -1 is 1, -2, and so on. For square root, square root of 0, 0, square root of 1 is 1, square root of 4 is 2, goes in this direction. And then a cubic function, 0, 0, 1, 1, 2, 8. Okay, and I might ask you to label a couple points on these to make sure your graphs are clear. Okay, for practice, go ahead and try to use what you know about transformations and parent functions to graph the following graphs. Pause the video and then check your answers when you're done. Okay, go ahead and check your answers. I wrote the transformations down, although you did not have to. And I could potentially ask you to label a few points. Your graph should have generally the correct shape, and they should have arrows if they extend to infinity in one or both directions.